So we end up using this sludge. You put it under a relatively high pressure and a moderate temperature, and it breaks down the cellulosic material all to produce two products: a bio crude, which is very similar to a fossil crude, and a biochar. If you're emitting loads of carbon, you bolt them on to capture that carbon. You're better off trying to find something that could reduce the emission of that carbon in the first place.
Hey, James, thanks so much for joining me today. I really appreciate it.
No problem, Jack. Pleased to be here.
So tell us a little bit about yourself.
Yeah, so I'm James Highgate. I'm the CEO of Firefly Green Fuels, and I guess I'm a bit of a geek around sustainable fuels, and that's hopefully today I'll tell you a bit about what I've been doing over the last 20 years and where I see this business moving over the next 20 years.
Oh, go on, I'll bite. So sustainable fuels. So let's dive straight into it.
Yeah,
So for those that aren't necessarily familiar with the world of sustainable fuels,
mm,
would you mind just breaking down?
sure. So I've worked in renewable fuels for over 20 years, and we're always very keen to produce fuels with the lowest carbon impact that you could possibly. And typically we look at fuels that you could make from waste. So I started with originally making biodiesel out of waste oil and fats. In fact, that was for myself, and it turned into a business, and we supplied equipment everywhere. And now we're very much looking into other sources of feedstock and other fuels to produce. But when you look at the world, if you look at transport, there are a lot of areas of transport that can be solved with other means. For example, like the road fleet can be electrified. I drive electric car, have done for many years, and you can see how that can work with cars. You can see how hydrogen could be incorporated into the road fleet, etc. But when you start looking in certain areas where you need a very energy dense fuel, you need to be looking at things that are similar to hydrocarbon fuels, but ideally without the fossil carbon in them. So as a business with Firefly, we are very focused on these sorts of fuels. So the production of fuels for things like aviation. So if you want to move something, if you want to fly an aircraft across the Atlantic, you are going to need to use a energy dense fuel, so you still have space in that aircraft for people, basically. So within Firefly, we've developed a sustainable aviation fuel. It's actually produced from one of the most troublesome wastes that are out there, but also one of the most abundant wastes that's out there. So actually, we're making out of sewage sludge.
Sewage sludge. Okay, so how does sewage sludge somehow get transformed into something that can be used in an airplane?
So I suppose what I've learned over my time in work, with clever chemistry, you can make all sorts of things into fuels. We looked at sewage sludge basically as a very abundant waste, and it's a very abundant waste that is wholly biogenic, i.e., that is made of carbon that has been recently fixed in a plant, or originally in a plant, but then either eaten directly or through an animal which has then been eaten. And so the carbon cycle is really small. So actually, from a carbon point of view, it's quite an interesting feedstock to be working with. The problem with sewage sludge, as you might guess, is there's a lot of water in it. It's very wet. So we started looking at different routes of how you could process these sorts of materials into something useful, into a useful fuel. So we looked at different thermal processes. So you can dry it, for example, turn it into a gas, reform that gas and made that into a fuel. The energy balance didn't really work with that. So we looked at other sort of routes. And we started within our research company doing some work around a process called hydrothermal liquefaction. And it's quite a magical process in a way, because water's abundant. We use waters everywhere, but actually as a substance, it's quite strange. It's quite if it freezes, it floats, it becomes lighter as it becomes a solid, which is odd. But also when you put it under things like high pressure, it actually can start to act as quite an aggressive chemical. So we end up using this sludge. You put it under a relatively high pressure and a moderate temperature, and it breaks down the cellulosic material, all of any residual fats or anything else that are in that sludge, to produce two products: a bio crude, which is very similar to a fossil crude, and a biochar, which is effectively, it's got the nutrients in it, some of the carbon from it. And when you think about it, you step back and think about it, well, this actually isn't too different to what you would find has happened in the Earth's crust over millions of years with organic substances that have under high pressure in the Earth's crust and moderate temperatures and and water broken down into crude oil and things like coal. Once you've got to the point of having your bio crude, so your effectively your crude oil, we've developed alongside our catalyst license or a process which isn't too dissimilar to that used in downstream oil and gas processing, so through hydrotreatment, to turn that crude oil into various fuels. We're focused on an aviation fuel fraction, but we will also have a gasoline fraction, for example, from it, and a smaller diesel fraction from those fuels. And so that's essentially how you turn sludge into jet fuel.
I'm sure that description has put quite some interesting images in people's heads
Yeah,
as they listen to this conversation.
yeah.
But I guess so. If I get this right, so you take the sewage sludge from a water company, for example,
Hmm.
and you put it under extreme amount of pressure. You apply, you take it through a process, and then you eventually, by hook or by crook, you end up with a biocrude, which you can then use to power jet engines or something, right? Is
Yeah,
that
yeah,
correct?
exactly. That's exactly right. And the final product that we produce, so once you made the biocrude, we then go through a hydrotreatment to then fractional distillation to get our range of fuels. And yes, the major fraction that we're focused on is the aviation fuel because that's the hardest to decarbonize fuel. And so that's where, if you're going to put your efforts into anything, that's the one you need to be putting your efforts into.
Wastewater sludge. So how does one get their hands on a load of wastewater sludge?
Yeah, I wouldn't necessarily want to get your hands exactly on it, but so basically what we are
Yeah.
so what we're taking is so wastewater treatment industry and and within the wastewater treatment industry, the sewage sludge is treated. It goes through various treatment steps. We're taking the material at the end of the process. So this is a material. I call it sewage sludge, but actually it's more commonly known as biosolids. And this is a material that currently gets sold to farmers and spread on their fields. This is a practice that's likely to be or will be banned over the coming years. So the wastewater industry is actually looking for other routes for this material. I think if you go to other countries such as Germany and Japan and a few others where it's already been banned from being spread on the land, typically this sludge is incinerated, but that leads to quite a high gate fee because it's 80% water. It's quite difficult to set fire to. So you've got to go through a process to get it dry enough so you can actually incinerate it. So it is a material that is there and is looking for a beneficial home. And then I think from the sustainable aviation fuel side, we're very interested in anywhere we can get a true biogenic carbon because the carbon that's in this sludge it's been fixed from the atmosphere really within a matter of weeks or a matter of months. It's a very short carbon cycle. So for us, it's like the perfect feedstock. It's like brown gold.
It's quite a description. So is it valuable or of value to water companies? Are they wanting to get rid of it? Are you solving a problem for them? Or is it something that actually there's a bit of competition for?
So because it's like to be banned from, it will be banned from being spread on farmland because there isn't the land bank effectively to deal with the nutrients that are going on. There is a competition for this material because it is actually typically it's quite a troublesome material to do anything useful with, and that's where the beauty of this hydrothermal liquefaction process comes in, because actually it's a very good way to process these wet waste. So I feel what we're doing here is we're offering a solution for the water companies down the line. And the last thing everyone wants to see is water bills going up because there becomes a very high gate fee on the disposal of this material. We also, so you might think, oh wow, that's being taken away from the farmers. How are they going to? Is this going to be offset with other fertilizer for their fields? And so actually it's not, because the co-product of the production is, so we produce biocrude and a biochar. Actually the nutrients and stuff tends to be in the biochar. So biochar is well known as being a soil improver. It's more of a precision fertilizer than the sewage sludge. Improves the overall quality of the soil. It holds water. There's lots of real big benefits from this. In our ideal world, is the biocrude goes off for processing for use in fuels, and probably aviation fuels and heavy marine and things like that that you can't decarbonize easily any other way. And then the biochar goes back to the farmland, so you're still providing the fertilizer, etc., that's needed there. Obviously, there's a sounds very simple at a high level. There's quite a lot of complex chemistry in the process, but there's also legislative things we need to sort out because these are two new products that we're producing, and so we have to get them qualified and certified for use, etc.
And I guess just on that point, once you process it and you find yourself with the processed biocrude,
Yeah.
what steps are between that point and a say an airline actually being able to make use of it within their planes? Do planes need to be re-engineered to be able to make use of this sort of biofuel?
Yeah. So this is one of the amazing things about this fuel and other sustainable aviation fuels that are being developed is that what we're doing is we're effectively producing a fuel that is a true drop-in fuel. So it's very similar in composition to a fossil jet fuel. It's just that the carbon in it has been fixed a few months ago rather than a few hundreds of millions of years ago. And so that's like the difference. So actually for aircraft, no, there's no change. This just gets this will get put in because it is a completely new fuel that we've developed, and we are having to go through a qualification process, and that's where we're focused now, is actually getting it qualified for use in aviation. And it's good to know that the aviation industry is very risk averse, and so you have to. It's a very rigorous process, which is going to take some time to go through to ensure that it's completely safe and is a true drop-in fuel and will cause no issues to existing aircraft. But all of the data that we've got to date and all of the testing we've done it's all looking really positive that this will be a fuel that not only could go in as a blend, but actually shows potential that could be used as 100% fuel, which is which is amazing, really.
Yeah, it is. It is. Yeah. And surely with the amount of pressure that large airlines or the aviation industry are under at the minute to shift over to sustainable aviation fuel, surely this is quite an attractive offer for them, or not visually attractive, but it's quite an attractive offer because of the sheer amount of feedstock available to them produce it. In the world of sustainable aviation fuel, outside of sludge, how does it typically get produced? What are the alternatives?
Okay, so there are, and this is interesting. So fossil fuels, drill a hole in the ground, and I know it's not quite as simple as that, but drill a hole in the ground, pour all out, make enormous quantities of fuel. With our process, as with many renewables, actually the potential volumes they're really significant, but they're probably smaller than fossil fuels. So you need an array of these solutions to work and take place. So you're quite right. We're not the only ones doing this. There are other routes. So if you look at available sustainable aviation fuel today, the fuel that's being used on the market is almost exclusively made from it's called hydroprocessed esters and fatty acids, HEFA. So this is processing waste cooking oils and fats and vegetable oils, etc., into a fuel that can be used in aviation. You're also seeing processes like ethanol to jet, where you can convert ethanol into aviation fuel. There's other routes that are looking at industrial gases, for example, and turning them into fuel. And then there's things like e-fuels, where you're using typically getting carbon from a point source, ideally a biogenic point source, and actually going through a process to convert that into a sustainable aviation fuel. The reality is we need all of these, and we need all of these to work to have a big impact on aviation. What we're quite excited about with the process that we're developing is that it could be a very significant proportion of the overall mix. So because of the availability of the feedstock, when you look at the UK, we think actually the overall SAF demand for the UK with sludge that's available today, we think we could probably meet probably 40% of that SAF demand for the UK, and that's a 10% blends. It's really interesting. The UK is unique because we use loads of aviation fuel. We're a big aviation hub, lots of planes flying in and out. When you actually look further afield and say, okay, how might this work in other countries? For example, you look at somewhere like Mumbai, where there's Greater Mumbai, 25 million people. There's a lot of upgrades happening currently and there will be over the next few years to the wastewater treatment system. So there's actually going to end up being a lot of this sludge available there. We did some basic calculations, but actually the sludge within Mumbai could provide 80% of the aviation fuel needs of the airport. So not just the SAF needs, the sustainable aviation fuel needs, but the overall aviation fuel needs of the airport. It's amazing. And then the nice thing with this process, this material is available everywhere. we're all contributing to the supply every day. In fact, Jack, you would have made probably
And
4 to 5 liters of SAF in the last year, and everyone would have done. So we just haven't utilized it yet. Thanks, by the way.
I was going to ask about that. So, what is I guess, the potential capacity or production capacity at an individual level? Did you say 4 to 5 liters?
Yeah, so 4 to 5 liters per person per year of SAF, and you'll probably make a similar amount of bionaphtha, which is gasoline. That's good going.
Okay.
Yeah. So when you look at it overall,
Yeah.
yeah, say eight to
Doing
ten.
my bit for,
Absolutely,
yeah,
absolutely.
just doing my bit for the environment. So, and thinking about it from an airline perspective.
Mm,
So let's say British Airways or Ryanair or
yeah.
whoever else. Thinking about the sort of the choice of different sustainable aviation fuels
Yes.
and their need, the industry's need to have a bit of a mix and a
Mm,
bit of diversity. How would an airline choose which fuel to go for? Are there different sort of factors depending on, say, the planes or the types of journeys or the availability of feedstock or something?
the most important things for the airline is the overall carbon saving and the demonstrable carbon saving of the fuel that you're using, because that's the whole point of this, is trying to help decarbonize aviation as much as we possibly. And that's why even when you look at short haul, you'll see some electrification, you'll see some hydrogen flights there, which are great. We need all of these. We need all of these things. But when you're looking specifically at SAF, the choice will be on the overall carbon saving, and that's because there are things called emission trading schemes. And if you can demonstrate the fuel you're using shows a greater carbon saving, actually, effectively the cost of that fuel to the airline will be effectively lower. So the overall cost would be lower. So that's one of the things. And we've undertaken a completely independent life cycle assessment of the fuel that we've produced. In fact, it was done through the incredible team at Cranfield University, and they found that our fuel showed a greater than 90% carbon saving over the equivalent fossil jet fuel. So that's, yeah, it's really high.
Wow.
Yeah, so it's amazing. And so it's one of those things where actually ours would be potentially of greater value to comparables. And so it's but I think that's the main driver from the airline. I think the other thing that's good is it's because we're using a true waste that's there, and there isn't really any other good uses for it. It's kind of a win. Having these
Yeah.
sort of supply drivers as well as the demand drivers is good. That's where you want to be.
And just as you said that, I was thinking about how the decarbonisation journey within aviation compares to, say, other large industrial sectors. And often you see a bit of a drive or a bit of a push towards carbon capture
Yes.
within the process. So the process still incurs as normal.
Yeah.
The emitting process still occurs as normal, but then you're just trying to capture the carbon that comes out of it.
Yeah.
Whereas actually in aviation, it almost seems to actually be a lot more mature in that they're starting right from the start point
Mm.
in just trying to decarbonize what goes into that process, which just to me seems such a better, more advantageous way to think about it.
Yeah, and I think that's the important thing. You want to go with anything. They should be looking at anything. Carbon capture should always be seen as like but not last resort. It's good to be doing it, but it is almost like a last resort. So it's a bolt on for whatever. If you're emitting loads of carbon, you bolt it on to capture that carbon. You're better off trying to find something that could reduce the emission of that carbon in the first place. If you wanted to hit net zero, the requirement for carbon capture would be just mind-boggling. I'm not sure how feasible in reality it would actually be. It's not just aviation. I think there's lots of industries which are looking at just going to either no carbon, so having lots of solar, wind, or whatever renewables there to power, which is great. That's exactly what you should be doing as a first choice if you can do it in that area. The difference with aviation is that it's actually, because of the nature of it's quite amazing that we can these huge vehicles can be flown across oceans, and it's
Yeah.
mind-boggling to get around that, how this actually works. But you can't. They've been wholly designed around a specific fuel that's available. To actually redesign the airframe for hydrogen, which would, even when you compress it, it still takes up quite a lot of space. So you need to change the whole airframe to be able to do something with hydrogen. You also have to think about how the hydrogen is made in the first place. Where's that energy coming from that's doing it? Or again, with electrification, heavy batteries, quite difficult to do on long journeys. So there is for the foreseeable future a real need for SAF. There is also a real need for significant innovation in all these other things, though, because there's a long way we've got to go to actually go to completely decarbonize aviation and actually to completely decarbonize all of these sectors.
It's a really interesting point because if you look at other sectors, particularly on-road cargo,
Yeah.
the pushes towards hydrogen fleets
Mm.
and creating much moving towards using hydrogen as the fuel source, or
Yeah.
obviously electric vehicles as well. But because of so it's interesting to hear you say that actually that isn't so much of an option in aviation. What does it look like for like sort of cargo ships? Like will we see the Masks of the world move over to an equivalent sustainable fuel, or are they going down a different approach?
Yeah, I think we will. I think the interesting with a lot of these products, like the one we're producing, is you don't typically just produce one fraction. You would typically end up with a number of, similarly to with fossil fuels, you end up with a number of fractions. When you start looking, basically, if you want to move something big a long way and have space to put things in, the hydrocarbon fuels are pretty amazing when it comes to when you look at the energy density of that product. You don't have to take up much space with your fuel to move your vehicle a long way. And so for cargo ships, now I think that there will be, that's the other area where liquid fuels should probably be being used. Whereas there are areas that certainly for cars, electrification, especially if you can decarbonize the grid fully as well to make sure they are fully renewable, is correct. Hydrogen as well you should be looking at. But it's interesting when you start looking at this. There are quite a lot of little things you've got to check. I.e., is the electricity being used renewable for producing these fuels or charging? And obviously that should be. Where's the fresh water coming in, for example, for hydrogen production? How do you do that? Is that it's quite complicated. But and there's a huge amount of innovation across the whole sector, which is really exciting. You reach these sort of stages where we have to change, we have to do things differently. And I guess from an engineering point of view, it's really cool that we have to come up and we've got to invent new things that are going to
Yeah,
do this.
it's
It's a pretty challenging time at the
and
moment, but it's really
remains.
exciting.
Is there policy coming in within the aviation sector on having to actually push towards using SAF?
Yeah, there is. And so there is already policy. In Europe, there's policy now in place. There will likely be policy very soon in the UK. There's a framework that's happened and in the US. And so there is policy coming in that's driving this forward because you do need that, because otherwise you end up with competitive distortion. It's very difficult for an airline to say, okay, we are going to commit to use a sustainable aviation fuel. Actually, this fuel is going to be more expensive than a fossil jet to make, certainly in the very short term, because if fossil fuels are really inexpensive. Even when you think they're expensive, they're not. They're typically cheaper than this in lots of places. That's what you're competing with. So you need policy that actually will allow that and drive that forward. And that's why things like the emissions trading schemes and things are so important, to say, okay, there is something there that's encouraging airlines and such to actually use these sorts of fuels rather than offsetting or rather than doing anything else. But yeah, absolutely, we need it, because otherwise the same thing would continue to happen, because an airline wouldn't be able to compete with others that
Yeah.
weren't using sustainable fuels.
Yeah, as with the world of decarbonisation, often people have to be given that little nudge by
Yes.
way of a bit of policy pointing them in the right direction. Eh?
Yeah.
But what do the actual mandates look like within the aviation sector?
So policy is incredibly important. So you do need policy to actually drive this industry forwards. And when you look at the global targets for SAF, they are immense. And even when you look at the UK, so we have a roadmap now which is aiming towards 10% of all aviation fuel to be sustainable aviation fuel by 2030. That's actually increasing to 75% by 2050. So we are talking about huge volumes that are going to be required. And so when you look at this, the potential growth of this industry driven by policy, the actual employment needs, we're talking about thousands and thousands of green jobs that will be required to actually deliver this. And so it's a really good thing to be, I think, to be looking at now. If I was a student at university, I was thinking, what sector am I likely to get employed in afterwards? Well, I'll be looking at this and thinking, wow, this has to grow, 1,600 times in the next few years. That's got to be a fairly safe bet for a job. It's great that policy is driving this forward. And it's not just in the UK, obviously in Europe, North America, and all over the world, there are now targets and mandates coming in place for an increasing volume of SAF, because it's the only real way we're going to be able to move towards decarbonising long haul aviation.
In terms of the production capacity in the UK when it comes to wastewater sludge, can we meet those targets? And do we have enough sludge to be able to actually meet those mandates?
So not just on sludge, no. So that's why we need more than one. That's why you need more than one,
Okay,
basically BMAs. Yes, I think we could do about 4% here, possibly 50% of the SAF requirement. So it's a big chunk of it, but we're going to need other sources as well. And it's quite nice as well as an industry is although there's other SAF developers out there, it's quite collegiate where we're not really competing because the demand far outstrips supply, and actually the demand will far outstrip the supply for the foreseeable.
brilliant. Hey, James, this has been so fascinating to learn. I think it's a world that most people won't be familiar with at all, particularly about the exact process in which
Yeah.
this particular type of sustainable aviation fuel is produced. It's just absolutely incredible example of engineering
Oh, thanks,
come
Jack.
to life. Thank you so much for your time. I really appreciate
Yeah,
it. I'll
no,
see you soon.
really enjoyed it. Yeah, no, thank you for your time as well, Jack. No, it is one of those things that is generally, it's cool. Returning sewage into
It
jet
is.
fuel doesn't get much better than that.
Cool. Thanks, James. I'll see you soon.